guys, right, this is a prequel to the intro. I hadn't actually realised that I had pre-shot the first part of my electronics video back in November last year, because I kind of got put off of it because somebody accused me of plagiarism and stuff like that. So this is pre-recorded for November last year. I'd forgot I'd shot it. It's being released on pre-release. Get my teeth in, pre-release early to my Patreons. Feel free. I should just start this all again, but I'll no bother. To support my Patreon channel, I'll put the little link up below. It'll be coming out early on my Patreon channel for the patrons that support me. Obviously, I'm not working, and I've spent out equipment to try and make things easier for you guys to understand and explain things. You don't have to. Tiers start from $1 a month. I think the highest one's $5, or you can do random ones. The whole idea is I maybe recoup a wee bit back against my equipment, but I'm not really worried about it. At the end of the day, I like to share knowledge. I'm not an expert. So I pre-recorded this back in November. I was kind of put off doing it. I'm now going to do the series, and you guys are getting to see it first on my Patreon channel. Obviously, when it goes live, folk will go, oh, all right, oh, it was early on Patreon. Yeah. We'll try and explain how to put electronics, lighting, and that into your kit, going from a novice level and breaking it down into little stages. So, apologies, it's about an hour long, but hopefully you guys will get a bit from it, and if I break it down into manageable sections, the future videos shouldn't be an hour long. They'll just be like these sections talking about this subject, that subject, that subject. Hopefully you enjoy it. The only way I'll know if you like it or if it's helpful or whatever is if down in the comments section you put your comments in. Obviously patrons on the early access, I'll get it first. And let me know what you want to see, what I need to explain more. Do I need to slow down on some bits? So, hope you enjoy it. If I do use any circuits that are available on the YouTubes already, I will, of course, tell you where I got them from. That way I avoid the plagiarism sort of thing. For those that don't know what plagiarism is, it's basically taking somebody else's idea and putting it up as your own. Electronics is free for all. It's openware. You can study at college, books, or on the interwebs. So it's not really plagiarism, but it's just to cover that aspect so I don't get accused of it. And I hope you enjoy this first segment where I talk about basically stuff we're going to need if you're going to follow along with me. And hope you like it, guys. It's a big topic to cover, so hopefully I break it down into manageable sections. So, as always, happy modelling, and hope you enjoy the video. And over to me in November. Right, hopefully this is working. Take one. Hiya, it's Terry from Smoo's Workshop here. Yes, 7 o'clock on a Wednesday morning. Yeah. Thanks for tuning in, guys. This is going to be a sort of introduction to, you might have watched my channel update on what I've got planned on the electrical side of things. I've had a lot of really good feedback from you all. Thanks very much about what you would like to see. So I'm going to cut across to a really rather messy bench because what I'm going to talk about in this first part of the series before we even get into doing circuits and stuff is the kind of stuff that I use and you guys might need if you want to follow the series and replicate what I'm doing and lighting up your model with LEDs. So I'll briefly run through some of the tools that you will need and things like breadboards, some of the components that you'll need, wire, solder, battery, power sources, all that sort of thing. So yeah, I've got so much stuff. It's trying to show you in order. So the bench will be a little bit messy, but hopefully I'm going to try and keep this to a nice under half an hour thing. But if you're thinking about lighting up your kits, and I'm going to be doing a series of videos working on the breadboard and showing you guys how to wire up an LED, make it light up, and how to make it flash, and how to do two, and how to do indicators, to relate to stuff that you guys might build, like cars, where you'll have headlights, rear lights, brake lights, indicators, possibly interior lights, and things like that. I'll run through standard LED stuff, and I will touch on briefly what nano LEDs are and stuff like that, and just kind of the components that you'll need. And hopefully, once I've done all that, you can sort of look back and say, right, that's kind of the things I'm going to need to follow Terry on this. And it's not how to, it's more an instructional series on LED wiring. I'm not an expert, okay? There are lots of videos on the YouTubes that go into quite a lot of technical stuff about how the 555 timer works and flip-flop circuits and all that. You don't really need to know all that as long as you know what pins to connect your wires to and how to adjust things for your timing and all that sort of thing when we get onto the flashing side. So the idea behind the series, once I've showed you all the stuff, or at least the basic stuff you'll need to follow along with me. Excuse me, I've got hair on my tongue there. So you can follow along with me. We'll go along a progression for the really simple stuff, onto really simple flashing circuits once we get onto it. Not in this one, but when we do the series. And then we'll start moving on to the more difficult stuff with a single 555 timer doing an indicator circuit, or doing flashing two-tone lights. I've actually got a breadboard wired up at the moment for testing out some nano LEDs. I'll maybe run through that if I get time. Later in the series, it's going to be like a step by step, tell you what components do, how to put them in, how to put them on the breadboard and everything like that, which is all fine and well, drawing circuit diagrams, you know, and how to relay that from getting it to work on the breadboard to actually putting it in your model. I've actually ordered a model. I'm keeping it under wraps at the moment, but it is a car. And my aim is that I hope to get 2 or 3 of these little instructional videos out to at least get you started in practicing on your breadboards before I start the car build series, because what I'll be doing in the car build series is, apart from, I'm going to do a step-to-step on building the actual car itself. Now, bearing in mind I haven't actually built a proper car kit for over 35 years, it's not so much going to be, this is how you build the car kit, but it's going to be how to put LEDs into the car kit whilst you're building it, and what order to do it, and what mods you have to do and stuff like that. That will be a separate build video series that I will possibly, if the kit arrives in time, announce on the Saturday live show. So in the meantime, I want to get you guys plenty of notice before I start popping the videos up, so you can follow along and do the experiments that I show you on them. What you'll need. And I've probably waffled on far too long already. And yes, my bench is messy, but I just want to show you sort of the stuff that these guys will need. So hopefully this helps you. There seems to be a lot of interest in it. I've not scripted any of this, so I'm going to kind of do it by ear as I go along. So this first video, when we come across to it and I stop waffling on, is going to be tools and stuff that I'm going to be using throughout the video series, and hopefully it'll give you an idea of what's involved and what you need to buy. It's really actually quite a cheap thing to put LED lighting into your models. The hard bit is actually, once you've got a circuit, once you've got it working, transferring that from a breadboard into actual wiring and hiding wiring and adding switches and all that sort of stuff. So I really do hope that I do this series justice. I'm not an electronics expert, and I just hope I do it well enough to rely on to you guys how to do it yourself. Maybe let you give it a go, you know, and make you more confident about maybe LEDs aren't really as difficult as what people think. And I will be looking for, especially after this video, comments in the section down below, because I've had a lot of feedback already. There's people with disability problems where they can't use all their fingers and stuff like that, and how would they solder something when they've only got one hand, and you know, they've got a fire engine kit, which I've got as well, and they want to do flashing blue lights in that. That will progress later in the series, but I think you've got to start with the basics before you work on, and it might be like teaching some of you guys how to suck eggs, but there's varying levels of people of abilities wanting to give this a try, so I'm going to give it my best shot. So bear with me, guys. It's not scripted, and I'm going to run through the stuff, and I'm waffling, and Terry, get to the bench! See you over at the bench, guys. How do I get this camera to go off now? Hey guys, welcome back. Right, apologies if this video runs a bit longer than what I anticipated. As I say, I don't script this stuff. So we're going to be basically learning together, or me trying to help you guys figure out how to use a breadboard and various components plugged into the breadboard to light up LEDs, which are little, think of them as a bulb, right? Little bulbs work on low voltage that you can add to your models to light it up, to recreate, headlights, indicators and stuff like that. So at some point after putting all your thing on your breadboard and everything, which I'll go into, you're going to actually have to solder wires onto resistors and LEDs and capacitors and all those little things that I'll go into. So we're going to be soldering, and yes, I will at one point in the video series show you how to solder things. Now, this is a soldering station. Now, it's not plugged in at the moment. The one I have got is ESD safe. ESD, what's ESD? ESD is electrostatic discharge. Some of the components, especially when we go into like the little IC chips, are sensitive to static electricity. And if you get static electricity into them, it ruins the component. So my soldering station is ESD safe, or electrostatic discharge safe. It means that it does not transfer any static electricity when I touch a component with the soldering bolt. So I'll just briefly say, so this is the control station. The one I have got is, and I will go into it more when we get onto soldering, this is a temperature controlled soldering station. It has a display at the top. It's not plugged in at the moment, so I'm not going to heat it up, but it's got a display at the top. It displays in degrees centigrade, and an adjustable rheostat or potentiometer to turn the temperature up and down in the display to get the temperature that you want. The reason this is important, although you can get one that will just go low setting or high setting, the reason this is important is a lot of these LEDs, especially when we get into the nano ones, when you buy LEDs off a site, usually the decent places will give you a spec sheet for them. They will tell you what voltage they run at, what current they consume. Standard ones are about 20 milliamps. Different colours take different voltages. And have I lost my train of thought? Voltages, blah, blah, blah. A spec sheet will tell you the maximum temperature you can apply to the leg or the contact pad on the LED before it will blow up. Typically speaking, most LEDs can take a maximum of 265 degrees centigrade for a maximum touch time of 5 seconds. You go over that temperature or you touch it for longer than the 5 seconds, you fry the component you're trying to solder, which is why I solder around about 240. And I dial in the exact temperature on there. Now, because a particular solder I'm using, I'm trying to remember what its melting point is, but I'll go into solder in a bit. I've got a lower temperature than the maximum rated on the LED, and I know that when I'm soldering, I count in my head, and if I start getting near 5 seconds, take it off, let it cool down, let the component cool down. If you haven't managed to solder it, So that's why I've got a temperature controlled one, okay? This is a soldering bolt. There's a heating element in there that heats up the tip. Now, this particular one came with a few different heads on it. So there's like a thicker chisel tip, different size pin tips, and all that sort of thing. So you can change the heads out depending on, obviously, if you're doing a large surface area, you want to use a larger soldering bolt, and if you're doing little nanos, you want to use a little pin type. So you can change the heads out. It also has a little docking station, and this bit of foam here, you soak it with water. It helps you when you want to clean the tip and stuff. So you're going to need a soldering bolt, whatever one you go for, right? But you're going to need a soldering bolt. The one I've got is, as I say, it's temperature controlled. There's a model there. It's a WEP 937D. It's all soldering station, ESD safe. That setup cost me about £50. It's going to be one of your more expensive things. You will need a soldering bolt when we get to the later stages. So that's soldering station. So I'm just going to move that off out of the way. Back in, it's kind of hidey hole. Sorry, you're going to see my arm moving in and that. As I say, I'm trying to cram loads of things onto the bench here. So I can see if I can get that away out of the way so I can move on. Yeah, you will comply. You will go back onto the bench. I had to unplug it actually to get to come that far across the table. So, right, okay, so that's a soldering station. Right, okay. So we all know we're going to be soldering. Right. To follow me in this series, you're going to need a breadboard, right? This is a breadboard. I will talk you through when I get into the series how to use the breadboard, what all the different holes are for, and stuff like that. But you're going to need a breadboard kit. They come in different sizes. Little ones, big ones. Oh, I'm just catching all my wires. I started off with a little one like that. That's a bigger one because you can use more. I'll just see what I've dropped there. Never mind, it's not important. Right. This is a breadboard. Now, a breadboard starter kit usually comes with a set of jumper leads. Okay, so these are little leads that I'll just show you on this. We plug in and out the pinholes to connect the circuits. Okay, so they generally come with a load of wires. So your breadboard kit should at least come with that. Okay, a lot of them will come with a selection of LEDs, resistors, little tactile push button switches and stuff like that. But to follow me in the series, you're going to need a breadboard kit, a starter breadboard kit. Some of them come with a little power USB power thing in the end, which runs at 5 volts. It's really handy if you're using Arduino, but I'm not using Arduino, so it's good to get one. This one came with one. If you actually progress further on later on, but you're going to need a breadboard with jumper leads in it. Okay, so I'm just going to move that to the side because we will need a breadboard with jumper leads in. Now I'm just going to put this to the side because this is actually a working circuit that I might get time to run through with you later on. Right, so we're going to have to power our breadboard. All circuits work with a battery and they go in a circuit. A circuit is a loop from the positive terminal on the battery, the plus, okay? It goes round all the wires, round all the things, lights it up all the way back, and it comes back to the negative or the minus, right? So to power our breadboards, we are going to need to be able to put power into it, okay? This one is a standard 9 volt. This is the cheapest connectors that you can get. See if I can pop it off. Probably not, but you know yourself that they've got like a round terminal and a grippy claw type one with 2 wires on, which enable me to, once you've soldered the ends up, you can plug them in into your breadboard. I find that 9 volt batteries put out a bit more current, so I mean that's kind of the starting point with all of my things. I'm going to be most of my circuits will be on 9 or 6 volts. So that's one kind. That's just a little clips onto the battery. The other ones you can get are little ones like these where let's see if I can. Right, this one takes 2, excuse me, AA cell batteries. Okay, so the AA is this size. Okay, and it takes 2 batteries, and they run in series. And when you add the 1.5 volts to 1.5 volts, and you've got the 2 batteries in there. One's together, the ones with the on-off switch actually, but there we go. Right, so imagine there's 2 little batteries in there. That's going to give me 6 volts, and it gives me the 2 leads coming off with an on and an off switch. That's really handy having the on and the off switch. So again, if I'm powering my breadboard up, I can plug in my plus and my minus into my breadboard, and I can run it on 3 volts using 2 AA batteries. I can also run it on 6 volts. Now there's a couple of different ways of doing this. You get a bigger one, okay, and that takes 4 cells. So 4 times 1.5 is 6 volts, okay. So you put your batteries in there, you clip it together. Again, this one's got an on and an off switch, and your 2 fly leads come out, and you can go into your breadboard and put it in, and that would be it running on. I'll just leave it there, but it's just for a quick demonstration. So there's one that runs 9 volts. That one's 3 volts. That would run 6 volts. Okay, if you want a 6 volt circuit. Now you also get, I'm just trying to see where I put it now because this bench is a mess. Right, you'll have heard of button cell batteries. Now, you'll get a lot of guys that will run LEDs off of button cells and they won't use resistors. I'll go into it in depth later on why you should always use a resistor. But these don't put out a lot of current. Okay, current is the amount of force that the power has to come through. It's not the voltage that does the damage, it's the current that sets things on fire. These are very, very low current, and you can get away in some circuits using these little, you get smaller ones as well. I don't have any here. You get smaller tiny ones to fit into smaller models. You get these little button cell batteries. Now I've got a single button cell battery holder somewhere in amongst all these things. I'll try and go into them a bit later on. Have I got one there? Is that? No, it's not. I do have them, but I'll show you later when I come across them. We've got a few drawers of bits and bobs I'll show you. So you get these. One of these runs at, now I'm just trying to remember now, 3 volts. Okay. So that pack there with the 2 batteries in, that actually, because it's a long AA batteries, puts out more current. Now, well, that's 3 volts and that's 3 volts. That can put out too much current and you've got to use a resistor. So that's why you've got to use a resistor. So you get these button cell batteries and you get another little power pack. This is a double one that when you put the 2 of them in, I've not opened this one yet, I don't think, but it will open. Okay, so you get 2 of those 3 volt button cell batteries in there. You can jerry rig it so you just put 1 in and you'll get 3 volts, but generally put the 2 in, that gives you 6 volts. That gives you the same as this big one, but you notice it's a lot smaller if you want to squeeze it into spaces. And again, it's got a positive and negative with a little on-off switch in it. So these 2, right, actually give out the same voltage, right? That one gives out a damn sight more current, which we'll go into later. But it's a lot smaller, and you can squeeze it into little places. And you actually get one that is a single thing. You can put 1 in, it gives you 3 volts, which is the same as that one, but it's only like that size, you know? But that gives you more current and lasts longer. So you will need a power supply. So whether you go for coin cell battery, 2 AA's, 4 AA's, or your standard 9 volt. I've actually got one of these cases that looks like that for a 9 volt as well. You can get them like that. So you will need a power supply. Okay, so that's covering the power side of it. So you've got your breadboard and you'll need something to power it with. Okay, so have a look at some of these little, get them cheap enough off the eBays and Amazons, right? So that's power. Right, power. Now, when we actually, as far as the breadboard side goes, I could just go into the components, but I might as well, while I've got stuff on the table, to clear it. Obviously, you're going to do your little circuit on the breadboard. You will eventually have to take all the components off of there, solder them together, and put them into your model. So you're going to need wire, okay? Now, generally for my positive and negative, positive is always red, okay? But not always, because you can get different coloured wires. And black is your negative, or I call it an earth, okay? I'll not go into all the technical V plus and all that sort of thing, but I generally, the dark colour is always the negative and the lighter colours is always a positive. That's what I do for extending my battery wiring and how I do my initial circuit. Now this is what they call bell wire. It's single core. It's got an outside diameter of about 1 millimeter. It's about 1.1 millimeter, the actual diameter of the wire. And this is solid core, so it's a solid core wire. The other ones you can get is stranded wire, which is lots of tiny little wires all going down the same thing. So that's bell wire. It's quite expensive, so I don't really like using a lot of that. I just use it, you know. If you don't have the money to buy reels of bell wire in that, and I'll go into it more when I do the wiring. You've got any Cat 5 cable kicking about, right? The stuff that you use to link your PC to your router and all the rest of it. Well, when you cut open Cat 5 cable, you have is it 3 or 4 twisted pairs? I can't mind because I've hacked this back. I think it's 3 twisted pairs. Right, again, they have an outside diameter of about 1 to 1.1 millimeters. You can get them, some of them are single core and some of them are stranded. This one's stranded. If you want to get wire cheap, get yourself a length of Cat 5 cable, strip it back, and you've got lots of nice twinned pair cables, and I can show you how to straighten them all up and everything. That's another good source of wire. I like to recycle wire. Wire's quite cheap. It can be quite expensive because copper's going up in price, so you could use Cat 5 cable, but you're going to need some wire. When we get into the nano side of stuff, sorry, that's the button batteries. When we get into the nano side of stuff, we're getting into micro wire, really thin wire. Now, I can't remember what the gauge of this stuff is, but this is Teflon coated, what they call magnet pencil wire. It's really, really, really thin. I mean, you're lucky if it's like 0.3 of a millimeter or something like that. We're not carrying very high currents, so they're enough, and that's for getting into really, really, you can see it's almost like a hair on my hand. When you're getting into these tiny little surface mount LEDs, we're getting into really thin wire like that. Another way that this comes, I prefer the Teflon one, is the other magnet wire that you get is enameled. So we've got a red, a green, and a sort of purpley colour. All this is the same wire, it's in that, but it's coated in an enamel lacquer, and you scrape back at the end and you can solder, and then the actual coloured lacquer on it is what insulates it. Not such a big fan of that, but I got that so I could have different colours, because when I'm running wires through vehicles, I want to know which one's the left-hand indicator, what's the right, and I do that by doing a circuit diagram and drawing down the different colour, so I could use green for right-hand indicator, red for left-hand indicator, and then I know that when the wires all come out to the respective place where I'm connecting all my stuff to. So that's kind of wire. So that's, I'll put that across there as well. I'm just piling it up. Some other wire that I've got in, again, it's pencil wire. This was a bit cheaper, and you can see it's coming all different colours there. Again, this has got a coating on it. I think it's a Kylar or something like that. It's not the Teflon ones, but I got some of these in as well, because I mean, that's 10 metres. Right, but if you look at my Peterbilt truck, which is like 18 inches long, if you're running a wire from the headlight in the cab all the way to wherever I'm storing, you're not too long in using up the length of the wire, so you do actually go through a lot. So that's kind of the wires that I use. Now, when you make a solder joint, you're going to solder the live and the negative, and if you just left it like that and touched together, it would short out and it would go on fire and stuff like that. So you'll need some heat shrink. Now, heat shrink is tubing that you slide over the wire. I've got a couple of different diameters there. It generally shrinks by, again, checking the spec sheet, between 2 and 4 times its original diameter. So if that one is 3 to 4 millimeters, it will shrink down to about 1.5. This stuff, I think, is 1 mil, and it shrinks. Is it 1 mil or 2 mil, and it shrinks down to 1 mil or just under half a mil. So some lengths of heat shrink to insulate. There's no point wrapping insulating tape around stuff. Get some heat shrink, yeah, because you can just slip it over, heat it up, it shrinks, and it insulates your joint. So that's that. You're going to need some solder. Now, that's a company that I use, right? 22 SWG, that's the weight. Now, the important thing for this is you want it a 60-40 SN is tin and PB is lead. You want 60% tin and 40% lead. Do not get lead-free solder. Right, I'll say it again. Don't get lead-free solder. I've got some. It's shite. Sorry, technical term. It's not very good. I'm just trying to see if I've got some there. See, that one's this is thicker stuff. No, see, that's a lead one. I know. I have got some lead-free somewhere. It's not very good. Okay, electronics companies still use lead. Right, leaded solder, guys. Right. If you want to know where to get it, right, that's where I get mine. You can get it on the interwebs, but yeah, 60-40 tin and lead mix. So you'll need solder. That is what you heat up with the soldering bolt onto the copper wires to join the wire to the component, or two wires together, or whatever. It's like welding, but it's called soldering, and it's pretty low temperature. I think that melts at round about 160 degrees centigrade, which is, so there we go. This is why we've got the temperature settings. If that melts at 160, we could melt it at 160, but it might take a little while to do it. So you've got your soldering bolt on your component that you're only allowed to hold it on for 5 seconds. So you take the temperature up a bit below. It'll all be explained when I get to soldering. You will need solder. God, I'm not half waffling on. Right. Later on, when we get to circuits that involve more than an LED and a resistor, which is your basic headlights and stuff like that, and we start getting the 555 timer chips and putting capacitors in, having something to fit them to make a little circuit board, right? You get these little circuit boards, right? They're just made out of fiberglass. They're all drilled out. And all the components go through the holes. You get different ones. I've got the ones with lines on. You get ones with little dots on. And what you do is you pop the component through, and you can solder the component to the board, and you can cut it to the size and make your own little circuit boards. So when we get on later on to the 555 timer chip circuits for doing like indicators and stuff, we will be making our own circuit boards. So you will need stuff like that, you know, to make your circuit boards. Right. Have I covered? Right, I've covered kind of what's on the table there. Right, okay, so that's that bit, right? Hopefully yous are all with me so far. God, I'm 20 minutes into it. Sorry for that. Right, now, with your breadboard and your leads and everything, you will probably find this is just you can get these sets as well, okay? Just looking for the opening thing. This is like a starter set, okay? And it gives you a few LEDs of differing sizes. These are 3mm and then 5mm, and it tells you there the different colours and all that, and a selection of resistors. Now, as I said, I'll go into it when I start doing the series, but you will need resistors to go with your LEDs. For example, a red LED normally runs at around about 2 to 2.4 volts. If you're using 3 volts on it, you've got too much electricity going into it, and the bulb will blow. So you then add a resistor in line, and I will explain it later on, that takes the voltage down to what's required by the LED. So you can get these little kits. This one actually comes with little things that you can, when you drill a hole and you put that in, and then the LED clicks into it and stuff like that. But that was just like a random kit. You tend to find you'll get a selection of sort of different coloured LEDs with your breadboard. So you're going to need some LEDs, and you're going to need some resistors, right? I have in here, in my main box, this is mostly my resistors, I have a selection of, open, right, I have a selection of resistors. Now, you can get carbon resistors, and you can get metal film resistors. I prefer metal film resistors. It's a personal preference. And they range, now they come in different wattage ratings as well. The wattage rating is what the amount of, it's a mathematical formula, I'll go into it later on. It's basically how much power it can handle. So most of the small stuff we're going to be doing, you'll get away fine with a 1/4 watt resistor. They start, I'll go into it later when I do the resistors, but they're measured in ohms, okay? So they go from 1 ohm up to 68 in here, and then I've got probably for 68 up to 270 ohms in there, and then we go into kilo ohms, which is times 1,000. So I've got 1,000 ohms or 1k, up to 1.5k there, and then I'm going to mega ohms and all that sort of thing. So I've got a selection of resistors. You can get, I got a bulk pack off of eBay that had like 10 of each, and they come in cardboard strips, the guys that feed them into the machines and everything. They come in cardboard strips, and I got a range from 1 ohm up to, I can't remember what it was, 10 meg or something like that. Is it 10 meg? Yeah, up to 10. Oh no, I've got kilo ohms there as well. No, aye, 10 mega ohms. I think that set was 10 quid. you know. And then when you find what ones you're using most of, you can go in and say, right, I want 168 ohm resistors or whatever. So your resistors, on some of the circuits, we are going to use things called diodes, okay? These are IN4001s. You get IN4003s and all that. They've all got different numbers. That's just what was on about. All your resistors in that will come on the machine tape. These are diodes. What a diode actually does, and I'll go into it later on, it allows the electricity to flow one way but not the other. All an LED is one of these, but it's a light emitting diode, and it lights up when the electricity is flowing through it. On some circuits, we will need diodes. It's when we get onto the more complex stuff, we won't need it on the basic stuff, but you may want to get yourself some diodes. What else have I got in here? That's just, yeah, it's a bit of heat shrink. I've got a few little LEDs in there. Right, that's fine. So that's resistors. Every experiment we'll do, we will need resistors. Okay? We'll go into that in depth when we're actually using them, but we will need resistors. For straightforward, when we do the straightforward circuits with the power supply, a resistor and an LED, that's all you're going to need, is the resistors to match the LEDs and the power supply and the wiring to solder it together. When we move on to flashing circuits and simple flashing circuits, we're going to need something called capacitors. Again, I'll explain what they are when I go to the section of them, but I have a selection of capacitors in here. There's like 21 picofarads, 10 picofarads, and all the rest of it. They're all measured. Get a selection of capacitors. I'll tell you how the capacitor works and a little experiments with them, but you will need capacitors. As soon as we go into flashing stuff, you'll need capacitors, right? If you're not going to do flashing, if you're just going to do straightforward headlight on or a bulb on, you won't need capacitors. But once we get into making things flash, we will need capacitors, or condensers, whatever they want to call them in German. Right, tool-wise, not essential, but recommended is a multimeter. Okay, a multimeter. My one's got a diode checker on it, which I use a lot. Lets us easily test what resistor we're putting in, what the resistance is, are we getting power to a circuit, and for checking diodes and things like that. Not essential, but if you've got one, it really is a lifesaver. Unless you want to start learning all the codes for the resistors and that, and I will cover that in the resistor section. It's a bit more to this than meets the eye, yeah. So yeah, this one's a Sykes Pickavant, but I mean, you can get cheap wee multimeters. Invaluable if you're going to be doing electronics, a multimeter, okay? So your big expenses are multimeter and soldering bolt, okay? All these other components are relatively cheap. Right, so we're going to go into, well, I'll take that out of there. Right, I'll move this to the side. As I say, this is all a bit higgledy-piggledy because I've got that much stuff to show you guys. Right, so, we're going to go into the whole idea of why we're doing this, is we want LEDs to light up. So, with your, so there's a wee pack of resistors, how they come, you know, on the machine tape. We're basically wanting to be lighting up LEDs. So, I've got all mines in little bags and stuff. Right, so you get all your different coloured LEDs in that, and they come in two varieties if you're going for the 3mm, what we call through-hole ones. You get diffused and non-diffused. Diffused just means it's cloudy or slightly opaque, and non-diffused is a clear. So like I said, there we go, I've got green diffused, they're 3mm, I've wrote on them that their operating voltage is 3 to 3.3 volts. When you're buying LEDs, you need to know what their operating voltage is, okay, and what amperage you run at. These are 20 milliamps. These red ones are the same size, but they run at a lower voltage, 1.8 to 2.2 volts, but they're also 20 milliamps. So when you're buying LEDs, it's important to note what the voltage and the milliamps is, because you'll need that later on when you do the calculations to find out what resistors you need for them. So I've got loads of different LEDs. You can actually get, now this might confuse people, these all look like they're white, but they're not, they're actually yellow. Okay, so you can get ones with clear lenses, but they show up different colours. Again, these are 3mm, and the 3mm is the size of the hole that they go through. Okay, so I've got various ones. Right, this will give you a better idea of the diffuse. I think this might run into quite a long video actually. Right, the ones on the left there, although they're actually red, right, these are flickering LEDs. I'll go into them as well. They actually have a little circuit in them, and they do a little effect on their own. But you'll notice they're clear, so you wouldn't know they were red. But see the white ones on the right, they're slightly cloudier. That's diffused, and that's clear. That's diffused. So you can see they're cloudy, they're not. Some other things that you might get with your kit are little tactile push switches. You're going to need some sort of switches to turn circuits on and off, and lights on and off, and things like that. I actually bought a big bag of, where have I got them? Right. When we start putting them into the vehicles, you'll need switches. These have 3 terminals on them. Yeah, they're double throw, single pole. I'll go into that when I go on to switches, but you're going to need switches to switch things on and off when they're in the model. You get all different types of switches. These are flick switches. These ones are little tactile switches where you press it, it's on. When you let go, it's off. They're handy for testing on the circuit board. I will go into this. This is a nifty little thing that is, yeah, only if we're going into the complex stuff, we will need some transistors. You will need NPN and PNP when we go into complex circuits. You're not going to need it for the flashing ones. All right. LEDs, 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 more LEDs. Tactile switches, LEDs, LEDs, more LEDs, different types of LEDs, ones that flicker. These ones, I used them in my shuttle build and my X-Wing build where I wanted to do the 4 engines at the back. These glow red, but they flicker. They flicker on and off. So you can get LEDs that do different effects as well. Not generally used on cars, but good for spaceships. Right, so that's nanos. Yeah, that's more flickers, ordinary greens, resistors. Right. These are... Right, this is something else. I'll go into it in more detail at a time. Instead of having... If you don't want to do a 555 timer chip because it's too big, and all you want is to do left-hand indicators and right-hand indicators, but no hazards, you can do it with these wee things. And I'll go into detail on them at the time. But these little chips will flash up to 3 LEDs, but unfortunately, because you would need 2 to do a left-hand circuit and a right-hand indicator circuit, when you go to do the hazard, they flash out of sync, which is why we use 555s, but I can show you uses for them as well. Again, we'll go into detail on that when we go into the actual component side. Right, a lot of these 3mm LEDs in that might be a bit too big for some of the applications we want to go in, and we're going to go into a different type of LED, which again I'll explain. They are SMD LEDs, or surface mount diodes. And they come in a range of different types. These are 0603s, which are literally, I don't know if you can see, but they're really, really, really tiny, right? So that's what you would call a nano LED. I buy them unwired because I solder them myself. So if you're a modeler, you should have, I'm just trying to see where I put mine, an optivisor, okay? You're going to need them if you're going to be soldering these things. You can buy them pre-wired. I mean, here's some more. These ones actually go 2 colours. They do green and yellow. And again, you'll see they're really, really small. If you're going to be soldering these things, you need you really need an optivisor. Right, this size of LED is a bit bigger. It's a 3528. This one is a dual again. It's a red and a blue. But I've also got a bag of these where they're a decent size to work with. They're about 3mm by 2mm by 1mm deep. And that type is called either PCC4, PLCC4, or 3528. They all get referred to, their sizes are different numbers. I've got these, that's the one I bought 100 of, so I got 20 white, 20 red, 20 orange, 20 green, 20 blue for my fire engines. And they were 3528s, okay, which are the same size as the ones that are floating about on this circuit board when I go to show you it. So you get them in different sizes, different colours. These are 06, 03s. These ones are red, and you'll notice on them. Now, it doesn't tell you on there what voltage you run at, but when I ordered them, I downloaded the spec sheet and it told me what voltage they run on. And again, these are, you see them? They're just tiny, tiny, tiny wee things. These ones are a warm white. Tiny, tiny. So we will go into all these little LEDs that you can squeeze into little places that you wouldn't normally get the bigger LEDs. Yeah, but these are called SMD LEDs, or surface mount diodes. Am I waffling on too much? Possibly. Right, okay. So I'm going to stick them back in. So for the first few experiments that we do with this board, you will need a power supply, right? You're going to need that. You're going to need your jumper leads that you got. You're going to need a selection of resistors, and it's easier just to learn doing it with the through hole type LEDs, the little 3mm ones, just because it's easier to show you on the breadboard. And if you get the circuit working with them, then you can then solder up your nano LEDs and everything. For tricking the basic circuit, it's easier. So you're going to need LEDs, right? You're going to need resistors, yeah, and you're going to need a power supply. And all the initial experiments that I'll be showing you with the straightforward bit will just be with these, with breadboard, battery supply, resistors, and an LED, whatever colour you want. We will then move on to battery supply, resistors, LED, and flashing circuits. We'll introduce capacitors and stuff into it. And then once we've gone through all the variants that we can do on that, we'll then add in something called the 555 timer chip. Now, how am I running? 37 minutes. Hopefully you're not all bored and I haven't bored you all to tears. That's one little box of my bits and bobs. So initially, for the first few experiments, as long as your board comes with some LEDs and some resistors and that you can do the experiment, follow along the experiments from it on the board. When we get a bit later on, these are some more tactile switches. These are 2-pin. Again, it's push to make it go on, but as soon as you let go, it goes off again. I was talking about the single cell ones for those button batteries. I don't know, can I pull my light across a bit? The single cell ones, I've got some here in the bag. Can I get one out? You have to solder your wires onto them, but that accepts one. There's no switch on this. So if you can imagine, if you're trying to hide something away, that'll give you your 3-volt power supply. And it's easier to hide that inside a model than it is to hide some of the bigger ones. When we get into the more technical stuff, we will be using variable resistors. Now, this is a big one. This is a pot. Okay. I'm trying to remember what. Is it a 10 kilo ohm? I've got it written on one of them. Is it a 10k pot? They have different resistances on them. What these are variable resistors, so you can actually use them on your circuit and turn them up and turn them down. And once you find the sweet spot, when we get onto the flashing ones, these are big ones, I've got smaller ones. When you get the sweet spot and it's flashing at the rate you want, you can measure what the resistance is across the pins and actually replace that with a resistor so it's at a set rate. I have things here that these are for a 10-pin chip called a decade chip. These will be used on later circuits. These just help me put the chip onto the circuit board and make it easier because I can just ping chip in. I've not really got much in that box. I thought I had more in there. What else have I got? Right, that's switches. Right. You may find it useful to get yourself some very small electrical connector box. basically just for ease of, you know, joining wires together when you're putting things together to battery packs and stuff like that. I will also, some of your faces may light up, this stuff is called fibre optic. Yes, at some point in the series I will show you how to wire up your fibre optic. It comes in various different widths. There's 0.25, 0.5. I think I've got 1 mil stuff in that as well. It can be quite pricey, but you know, what fibre optic's handy for? Imagine you're doing like a cockpit on a plane or a dash light on a car, and it's really, really, really small, and even a nano LED or a small through-hole LED isn't going to get there. You can drill it and put this really fine, it's almost like catgut, fibre optic up there, and the end of it will glow, and then lead that off, excuse me, to your LED. So yes, at some point in the series I will be talking about fibre optic cable and how to attach a fibre optic cable to your LED to allow you to put wiring, sort of lighting in places in the model that you can't reach or doesn't have enough room to get an LED into. Have I covered just about everything? I'm just thinking what else I've got. I think that's a good general sort of, oh no, right, okay, here we go. Right. I'll tell you about these when we get into switches. These are an interesting switch. These are little, I'm trying to remember the name of them now, but these just look like little resistors that you put in line. But that switch activates when a magnet touches it. Can you think of the uses for that? The lighting on your thing is off, but you put something on it with a magnet, it switches it on. There's lots of interesting little gadgets. That's more into the advanced side. What I have in here is the little 555 timer chip, what do they call them, pin sockets, for when we start putting things onto the PCBs, that we can solder this in and just insert the 555 chip. These are handy little things as well. When you're thinking about, you want, say you're doing a spaceship or something, but you don't want all the wiring visible. You could have that concealed inside the spaceship and have this little pin coming up out your dial, and then when you put the spaceship on, it lights up. I've got 2 or 3 of them. Right, have I got? Oh, here we go. This is a bigger style. Oh, my phone's low in storage, it's telling me. So I'm just going to finish up here. Another type of tactile switch. Okay. 555 timer chips. Okay. And decade timer chips. I will go into all them. I think I've ran on quite far. And also variable resistors or potentiometers in a smaller scale. Right. I'm going to cut this now. Because my phone's running out of memory. And I've run it in 43 minutes. And it's far too long. Sorry about that. But that's kind of what we're going to cover. So hopefully it's giving you an idea of some of the stuff. It's Terry from Smoo's Workshop, and sorry this first video went on too long, but maybe it might give you an idea of all the things we're going to be talking about. So until the next time, happy modelling. Bye.